Today, I'm going to show you how 3-wire RTD compensation works, using a PT100 sensor and my Fluke 289 multimeter. The PT100 is a resistance temperature detector. It measures temperature by changing its resistance. I've chosen a long RTD for this demonstration so that the wires themselves have more resistance, making it easier to show you the compensation effect. In a 3-wire RTD, we have 2 red wires and 1 white wire. The red wires are the leads that will be compensated. The white wire is the lead that carries the temperature measurement. Let's turn on the Fluke 289 and set it to resistance measurement mode. First, I'll measure between the white wire and 1 red wire. The reading is 111.83 ohms. If we check the PT100 temperature conversion table, that equals about 30 degrees Celsius or 86 degrees Fahrenheit. Now I'll measure between the white wire and the other red wire. We get the same reading as expected, because it's still measuring the same sensor, plus the wire resistance. Next, let's measure between the 2 red wires. This reading shows only the resistance of the wires themselves, and it's 0.56 ohms. Now that we know the wire resistance, we can compensate the measurement. It's very simple. Take the measurement between the white and red wire and subtract the resistance between the 2 red wires. With this compensated resistance, our temperature is now about 29 degrees Celsius instead of 30 degrees Celsius. It's not a big difference in this case. But if the wires are longer or thinner, their resistance can be much higher, and the error could be significant. And that's how a 3-wire RTD compensation works. Measure the total, measure the wire resistance, subtract it, and you get a more accurate temperature.